So MC of 100, we have 15,000. Oh no, we have 100. So it's 100 minus, now it's 0.002 times 100. And so it's going to be 100 minus what? 0.2. And these are in dollars? Yeah. So we're talking $99.80 is the marginal cost of producing 100 swings. Okay? That's MC of 100. And so now, actually, I bet you can interpret it. All right? So I'm going to pause and let you, based on what I did on the exam question, let you try to interpret it and check with someone near you, see if they get the same thing. What are the units of the derivative? Dollars per swing. That's right. Sometimes they won't write that, per swing. But we know that derivatives are always rates, and so it's per something. So when we write that out, I think that helps you interpret it, doesn't it? Okay? So I would say this for my interpretation. When 100 swings are being produced, each additional swing increases the cost, what? $99.80, right? It increases the cost by that much. $99.80. You guys follow that? I mean, if you looked at the original function, you might think that each swing costs you an extra $100, which is kind of true. But as the production levels go up, there's this little factor here. See, when the production levels get higher, and this is really the benefit that Henry Ford and others before or after him gave us, right? That's what you're measuring there. Okay? And it's very small because that coefficient is small. But in other applications, it could be bigger.
So this is
Go ahead.
saying that if you produce...
And you'll see, when you guys try the homework tonight, I did the same thing. I assigned ones that are like these.
Wait a minute. 5.3?
Yeah, 3.5. This is page 230. Well, 229. But what we're doing is taking the same situation. I have the swings. There's the function that helps me produce them. And now I want to determine, well, two things. First of all, AC. What does AC stand for? Average cost. Now, how do I get the average cost? What do you have to do?
The f of x plus change in x minus change in x.
Oh, you're thinking of the derivative, right? No, this, I guess the only example we've had so far is on the test. Or maybe we had one in class before. Tim, you have it?
Take the cost and then you divide it by how many.
Take the cost and divide by however many I produce, right? So if I know the cost, so guys, I guess there's two ways to do it. You could just use the cost function and then divide by the number. But actually, this is a separate function, right? Because they asked me for average cost of x. So let's see how I do it. I take the cost function. What is it? It's 15,000 plus 100x minus 0.001x squared. And I divide all that by what?
X squared?
Well, by x, because you divide by the number of swings you produce. Does this make sense? So that's called the average cost function. All right. So what does it equal? Well, I guess I could say that the average cost function is, how about we write it as 15,000 over x, right? We can split this up into three little pieces. Plus what? 100. And then minus 0.01,
Thank you.
no, 0.001x. Does that make sense to people? So this is the average cost function. Now they asked me for the average cost of 100 items, 100 swings. This might give you an idea of what you should charge. So what's the average cost of 100 swings? Well, we plug in everywhere that it used to say X, we're going to write 100, right? So I have to do 15,000 over 100. Then I have to add on 100. And then it'll be 0.001, well, times 100. And so I could use my calculator, but I could also just kind of work it out here. 150 plus 100 is 250 minus, well, a dime, right? So I'm getting that the average cost of producing 100 swings is $249.90. So you better charge more than $250 or you're not going to make any profit, right? So what are we going to list it for? $299.99? How's that sound? $399.99? I don't know. Depends what we could sell them for, right? Okay. So that's the average cost if I'm producing 100 swings. Sell them for how much? 800? These swings?
No, he's saying that they could make like iPhones for like $60. They said yeah, and then they sell them for like 800.
Exactly, right? It's all about, mass production. Developing an iPhone's not so easy.
That's true.
Producing an iPhone is much easier, right? So this is true. All right, so we did the average cost. Interpretation. How do we interpret it? Go ahead, Matt.
Cost to produce 100 patio swings is $249.90 per swing.
Good. I'm going to say when the production level is 100 patio swings. And that'll help me for both problems, because we're about to, remember there's another problem they asked me here. Not only was I asked to find the average cost, AC of X, I also asked, well, yeah, the way we wrote it was MAC, which stands for marginal average cost, right? So that is MAC of X, and that's the derivative. That's right.
That's the derivative of average cost.
That's the derivative of the average cost function. That's right. So we're about to do that. But let me finish what Matt was saying. When the production level is 100 patio swings, the average cost of a swing is $249.90. I figure if I want to help you get better at interpreting, I have to show you how to interpret, right? That's really my job here. Okay, so now let's compute the marginal average cost. Now, by the way, a couple ways we could do this. The first thing we have up here that we computed is this average cost function. You have to find the derivative of it, right? You could use the quotient rule, but that's the longer way here. You know what would be easier here? We already simplified it, right? Remember that? Because we simplified average cost. Let's use basically this line right here. Matter of fact, the way I'm going to write it, I'm going to write it as 15,000 x to the what? Negative first power plus 100 and then minus 0.001x. So when I take the derivative now, I think you'll understand that what I get is negative 15,000 x to the what? Negative second. There's bing, bing, right?
How did you get negative 15? Oh.
I got negative. You see where it came from? The negative one came down. Plus 0, right? And then minus 0.001. Is this okay? So maybe I'll rewrite it again. the marginal average cost of X is negative 15,000 over X squared minus 0.001. What are the units? Dollars per swing. That's going to come into play here in a moment, because the next thing they ask me to do is to find the marginal average cost of 100 and interpret it. All right, so what do I get? I get 15,000 over, do you guys know what 100 squared is? 10,000. So 15 over 10 is what I really get. 1.5. Negative 1.5 minus 0.001. So I get negative 1.501. And what are the units? Dollars per swing. Okay. So now my last job here is to interpret what I just computed. The marginal average cost of 100. We're going to say when the production level is what? 100 patio swings. How do I interpret this? What's, first of all, something increasing or decreasing? What's decreasing?
The marginal average cost.
Cost to produce one more.
Yeah, the average, okay, so the average cost, how about I'll say this, the average cost will decrease $1.50. I'm going to forget about that tenth of a cent, if that's okay with you guys. All right, I'll put it there. For each additional, what? Swing produced. Right? That can be helpful if you're trying to say, hey, should we increase the production level to 160? Well, how much are we going to save? How much more is it going to cost us? Right? Well, the average cost per swing would go down $1.50 per swing, so it would go down about 15 bucks. The average cost. That's what that's saying. Go ahead.
So the wording to me seems kind of similar. Can you explain the difference then between our analysis of average cost of 100 versus marginal average cost of 100?
Okay. For marginal functions, a marginal function is a rate of change, right? For the average cost function, I just told you, that's how much they cost per swing. Okay? But for the marginal, notice what it says. We're talking about the average cost. The average cost will decrease. Again, I said for each additional. I guess another way you could say that is per additional swing. It's a rate. Does that make sense?
So in theory, if you made 101, it should be the $249.90 minus
$1.50. So it'd be $248.40. That's right.
Okay.
That's what it says. You guys get that? A marginal function is a rate of change of a function. I think this is a nice example to show you, how those things play out. All right. Let's do problem 35. Problem 35 has a lot of pieces, parts, all right? Actually, if you have your book, this is on page 229, and it continues on to page 230. And I think I should probably stop and let you read and let you talk to someone near you, and then come back here in a minute. Hey,
You didn't.
what's that?
You didn't show us.
No, it's in the book, page number 35. So we're producing picture frames, and there's a little p. What's the little p stand for? Price. And we know that C is a cost function again. Okay? And now it's talking to us about revenue. How do you get revenue? Well, you take the cost No.
Price mix.
It really depends on the price, right? We need the price of the item. So we need the price of these picture frames. And what else do I need to tell you if I want you to tell me? See, revenue is the money we take in, right? How many we sell. We have to know how many we sell. So by the way, if I write this little formula for you, this may help. The revenue function is given by X times the price function. Does that make sense? Because what's X stand for? The number of picture frames we're producing. Okay? X is, or maybe the number you sell. Yeah, the number you sell. So I'm making an assumption in this problem. I'm assuming that everything we produce gets sold. All right? That's not true, I know. You could get a little more in-depth with your analysis, but you'll do that in marketing class. Let's just assume that X is the number we sell, right? And how about that profit function? Does that make sense to you guys? What's that say? Profit equals what? Revenue minus cost. Okay? And then the next line's kind of interesting. Find the smallest and largest values for positive profit. See, not everything we do, not every decision we make turns a profit. That's why my friend's uncle got out of the car business. He said, no way. It's not going to turn a profit.
The capital P is profit, lowercase p.
Capital P is profit, lowercase p is price. That's going to be our standard for our book. And I don't guarantee it's going to be standard for everything you guys study. You got to pay attention to what the source is on that. And then the last question says, evaluate P prime of 3,000. So P prime, what does that mean? We're talking about a rate of change of the profit, and we're evaluating that when the production level would be 3,000 picture frames. Okay. Anyways, there's a lot to do, so I better get to work or I'm not going to finish. Only have 15 minutes, huh? Something like that.
Yeah, but how can we get it?
Well, let's see. I'm going to start off just by writing down some of these different functions, right? We have the price function. We have the cost function. So I guess the first thing I ought to do is multiply those, right? So let's see. My revenue function okay, again, this is problem 35. My revenue function is, we said, X times P of X. So it looks to me like my revenue function is X times, well, negative X over 30 plus 200. Do you guys think I should simplify this?
No.
I mean, what am I going to do next? I'm probably going to be using it, right? I would simplify this one. Multiplying by X, isn't that easy? You know? Why don't we rewrite the revenue function as, I'll distribute the X. So how about I write it as negative 1/30th X squared plus 200X. Does that seem okay to you guys? I mean, there's advantages for writing it this way, and there's advantages for writing it that way. Kind of depends, I guess, what you're doing. We may end up using both ways. I don't know. We'll see. But there's the revenue function. So what did it ask me to do then? We were asked to, determine the profit function. All right, so all I have to do now is take that revenue function and subtract what? We have to subtract the cost function. So I'll take that negative 1/30th X squared plus 200X, and now I'm going to subtract, better put it in parentheses, 60X plus 72,000. Right? So now I'll have the profit function, negative 1/30th X squared, and then what would it be? It'd be plus 140X, right? Okay. Thank you. Plus 140x, and then minus 72,000. Well, that makes sense. Those are the fixed costs. So this is a $72,000 initiative, right? So that's the profit function now. Okay, next step. What are we doing? I think it said we want to compute, the values of x that'll make this a positive profit, right? So how do you do that? That may be confusing. Find the smallest and largest values for positive profit. You guys, what would the graph of the profit function look like? A parabola. Opening which way?
Downward.
It opens downward because that's negative, right?
Mm-hmm.
So, I mean, my picture is something like this. And see, somewhere right here, when x equals 0, no, not x equals 0, p of x, when the profit is 0, that's like your break-even points, right? So I'm trying to figure out what are the x values that make the profit 0. That's what I'm looking for. Does that make sense to you guys? Okay. I'd like you to talk to someone near you about how you might compute that. Go ahead. So we just had this pulled out. You guys remember the good old quadratic formula? Negative b plus or minus, what is it? B squared minus 4ac is under the square root. And then all over what? 2a. I mean, does that thing factor? I don't know. Maybe. Multiply by 30. I think this is probably the way to go. You have a calculator, right? Well, speaking of calculator, hey, let me put that in the calculator. I'm going to need it anyways. So, by the way, for those of you that want to do it this way, I should mention what I always do. Anytime I have a quadratic formula problem, I then write down over here exactly what I have for A, B, and C. A is what? Negative 1 over 30. B is 140. And C is negative 72,000. And those negatives make a difference, okay? So you get, let's see, negative 140 plus or minus square root of 140 squared minus 4 times negative 1 over 30 times negative 72,000 all over 2 times negative 1 over 30. I'll tell you what, I love teaching a calculus class because I'm just flying through this right now. You guys are looking like, yeah, that's cool. When I teach an algebra class, I put that, they're like, it's so much work! And they just go crazy. It's just funny, the complaining level. It's just different. Calculus, you guys are just used to being abused, I guess. Right? So let's see. Let's see what happens. We get negative 140 plus or minus, so I need 140 squared. Nice job, 19,600. And then minus, and then let's see, 7,200 over 3 would be, what do we got? Yeah, 2,100 times 4. Is that 8,400? Well, is it plus or minus? Minus. So 8,400.
No, I think it's.
Am I wrong?
It's 9600.
9,600. Yeah, trying to show off, Paul. All right. We want a calculator, don't we? Okay, so while we're on the calculator motif idea, let's see. We're going to, oh, look at that nice trig function. Inverse trig function. All right, anyways, let's go here. And I'm going to type in this function. So negative 1 divided by 30 times x squared plus 140x minus 72,000. Okay, let's graph that. Too bad we won't see anything. Oh, wait a minute. We should change the window. What should I change my window to? Well, they told me, right? They said 0 and 200 is what the thing is valid for. So I'll put a mark every 100 so we can see how many swings we're making. And now Y min and Y max, well, the profit, I guess what I'm really interested in is where does it hit 0, right? So why don't I say, like, I don't know, negative 1,000 and positive 1,000. And I'll put a mark every 500. And I'll hit graph. I mean, there's a lot of ways you could do this, I guess, but
No.
don't see anything. I don't see anything. You like zoom fit? Zoom fit's a nice trick. I could do that. Let me look at the window again. 0 to 200. Isn't that what we said the model's good for? Y min and Y max. We don't see anything. Oh! That was the last
I don't
problem.
think there's, I didn't see any,
Well, I got to look more carefully here. Does this say at all what the production level is?
not that I know.
No, it really doesn't. Although, you know what it does say? We're going to be evaluating P prime of what at the end of this problem? Well, maybe that's why. Maybe I can't see anything because we're talking thousands. So instead of going 0 to 200, why don't I go 0 to, okay, if we're going to be doing, yeah, 5,000 sounds good if we're going to be doing 3,000. And I'll put a mark every 1,000. So we're making, yeah, it makes sense. You'd make a lot more picture frames than you would patio swings, right? All right, so let's try graphing it now. Well, now I can see it. It's kind of a weird graph. You have to understand, what does it really look like? It looks like this if I get the scaling right. What am I seeing? I'm seeing where the x values are. You guys with me? So I want to find those. So here's a nice feature of your calculator. If you hit second calculate, you could do values, but you can also do choice 2. Hey, find a 0 for me. Then I won't have to use the quadratic formula. All right? But you have to tell it where. So my left bound, why don't I say 0? And my right bound is coming next. Well, let's see. Remember, each mark was 1,000. So why don't I say 1,000? And what this will do then is it'll find the zeros between 0 and 1,000. They even put a little arrow here. Do I have a guess? No. Just find it for me. What do we get? 600. Wow. So this works out really nice. By the way, did anyone get this from the quadratic formula? Did you get it? 600 or what? Well, the other one's bigger, right? So what's the other one? All right, you make me want to work out the formula. 3,600. Someone didn't want to work out the formula. 3,600? Let me test that. All right, so let's see. Second, calculate. You guys just want me to go home. All right, let's see.
No, we want to go.
You can go anytime you want. A value. Let me plug in 3,600. Just to demonstrate to the television audience at home that, yes, y is 0. Okay. So, my class wants to get out of here. You know, they have 6 minutes. But here we go. Crystal's out of here in 5 minutes. All right. So, now let's do the last part. Oh, no. So what's this say? You have to make between how many swing or how many picture frames? 600. You make less than that, you're not going to sell enough to turn a profit.
It has to be greater than that, right?
Has to be greater than that. Now, sometimes this doesn't make sense to people. Why would it be that if you make more than 3,600, you're in trouble? If you overproduce, what could happen?
Revenue goes down.
Why does the revenue go down? Because what's going down?
Cost goes up.
The price is going down. The price of the item is going down, right? And the costs. But in particular, the price. The price starts going down. You saturate the market, they say. Okay? So that's one of the issues going on here. All right, so then the last little step here, P prime of, what did they say, 3,000? Okay, so here I go. P prime of x is, well, how do I compute that? I need to use P of x. There's P of x. See if I can get them both on the screen. Yes. Nice job, Paul. All right, so let's see. When we take the derivative, we get negative, how about 1/15 x, right? Plus 140. And by the way, this P prime of x, another name for it would be the marginal profit. You guys okay with that? So that's the marginal profit function. And it says, please compute P prime of 3,000 and interpret. All right, I could do that. 3,000 was a nice one to give me because it cancels with the 1/15. So I'm sure that was done on purpose. So let's see. 20, right? Negative 20. So negative 20 plus 140. You guys with me? Is 120. What are the units?
Dollars.
Dollars per,
What are we making?
what are we making?
Frame.
Picture frame, right?
Negative 2,000, not negative 20.
Negative
Or
2.
Oh, you're right. That's different. Let's get out the red pen again since Paul's making mental math errors. Negative 200. Does that make a difference? Because now what's happening? Negative 60 what? Dollars per.
Frame.
What does that tell me? Should I make additional picture frames? No. Because every time that I'm making additional picture frames at this point, I'm actually losing out on profit. My profit is decreasing. Matter of fact, if you recognize this in your business, what do you think you would tell the people at the plant? Maybe we should decrease production, right? Definitely don't increase it. Do you guys follow? So this is what marginal costs are all about. The last question is this.
Not to interpret it.
Well, well, I just did interpret it for you. I said,
What last question?
the last question is this. Is there an ideal?
Yes.
What would be the best number of picture frames to produce?
2,100.
Set cost.
Whenever
The highest, but how do you find that?
Average.
What's that?
Take the average of the.
Okay, well, for this one, you take an average. Well, how do you do it in general? That's chapter 4. Come back Wednesday and we'll talk about that.
Definitely show up now. Now.
That's what.